In this video, we're going to learn about end behavior of a polynomial function. At the end of the video, you should be able to identify the correct end behavior of a polynomial function. Let's have first our review. A polynomial is a monomial or sum of monomials. A polynomial in one variable is a polynomial that contains only one variable. This is our focus and this is the example. As you can see, you have 5x squared plus 3x minus 7. Here we have three terms, so it's a polynomial and it has one variable, x. The last term does not need to contain variable, it's called constant. The degree of a polynomial in one variable is the greatest exponent of its variable. A leading coefficient is the coefficient of the term with the highest degree. Let's say, what is the degree and leading coefficient of 3x to the power of 5 minus 3x plus 2? Well, the degree is 5. It is your highest exponent. The leading coefficient is the number in front of the variable that contains the degree. Leading coefficient is 3, degree 5. Let's continue. A polynomial equation used to represent a function is called a polynomial function. Polynomial functions with a degree of 1 are called linear polynomial functions. Degree 2, it's called quadratic. Degree 3, it's called cubic. How do you evaluate? Well, you just substitute a number in the given function, and we've learned this in your previous lessons. This is how you evaluate, or you can have more terms involved in exchange of x. Now, let's deal with shapes of a polynomial function. Let's say if you have f of x is equal to 3, this is called a constant function. Whatever value of x, your y is equal to 3. So you have a flat line, it crosses on the y is equal to 3. The maximum numbers of zeros is 0. There is no roots for constant function. Let's proceed. You have here a linear function, degree 1, and here's an example, presuming it intersects at y of 2. The maximum zeros 1 because there is one intersection on x-axis. What if you have a degree of 2, which is called quadratic function? It has a degree of 2, and this is how the graph should look like. It's a U opening upward with intersection twice on the x-axis, which makes it maximum numbers of zeros possible is 2. Okay. Now, if you have cubic function, power of 3, its degree of 3. Supposed to be, it's only one intersection here, but a cubic function with more terms, it is possible that there are 3 possible roots, but since it's just a plain x cube, it only intersects once, it's on 0. If there's more terms, it's possible that it intersects 3 times on the x-axis. Higher, degree 4, a quartic function has a degree of 4, and this is how the graph should look like. And it has a maximum of 4 zeros because it has 4 intersections. 1, 2, 3, 4. That's the numbers of zeros. Okay. Degree 5, so there's 5. It's called quintic. You would rarely hear this name, quintic function, but it's for the function of degree 5, and it has maximum of 5 zeros. If you notice, it only intersects 3 times. There are 3 real roots. The remaining 2 roots are imaginary. Now, we are on our main lesson, end behavior. End behavior is just a description of how did the graph behave on both ends. That's why it's end behavior. So we're going to describe the left side and then the right side. We will start with a function that has an even degree, and the leading coefficient is a positive. Let's say fx squared. X squared, this behavior also works for power of 4, 6, 8, 10, and onwards, and it should have a positive degree. For basic, we will have the x squared. If you have power of 4, power of 6, they will have the same behavior. It might not be the same graph, but the same direction of the end of the graph. Now, what is the end behavior? This is how the end behavior is stated. The red describes the left side. It says here, as x approaches negative infinity, or as the graph goes to the left, because this is the left side of your graph, the function goes to positive infinity. Function represents y. Y represents the horizontal behavior. No, I mean vertical. Did it go up or did it go down? Actually, it went up. Up means positive infinity of the y, which is the f of x. This is the end behavior on the left side. How about the right side? The right side describes that as x goes to the positive infinity, as the graph goes to the right, the graph goes up. Up, it's because f of x is going to positive infinity. It goes up, and this is how it's described. This is the end behavior. And that's how you describe the end behavior of a polynomial function. And this is only the first case. Now, what is the second case? What if it's also even degree, but it has a negative leading coefficient? It can be -1, -2, it does not matter, but if it's a negative. What happens is, remember your quadratic function, if the leading coefficient is negative, which is the term or the coefficient of the x squared, the graph opens downward, which switches everything on your end behavior. This side always stays, because this one describes the left, this one describes the right end of the function, but these are the ones changing. Since they are both ends going down, this represents the y of the x-axis. Negative means goes down, so it both went down. The left goes down, the right goes down. This is how your end behavior, if you have a power of even, or the degree is even, and the coefficient is negative. That's the second case. There are 4 cases in all. Now, what is the third case? The third case is that your degree is odd and your leading coefficient is positive. Let's say you have x cubed. It can be x to the power of 1, x to the power of 5, x to the power of 6. It's the same. This is the end behavior. The more terms involved, the higher odd numbers, the more curls it will have at the middle. But the end behavior will never be different. If it's an odd, the right side goes up, the left side goes down. So how do you describe your end behavior? As the graph goes on the left, negative infinity, the graph goes down. It goes down. Goes down means the y is heading towards on the negative infinity. On the right side, as the graph goes to the left, no, on the right, the function goes up, positive infinity. So this is your end behavior. If you have an odd powered function, odd degree, a degree of odd, and a positive leading coefficient, this is the end behavior. Right up, left down. And that's the third case. And we have now the last case of the end behavior. If you have an odd powered degree function and the leading coefficient is negative, let's say you have negative x to the power of 3, it switches. The left goes up, the right goes down. So the left, as the graph goes to the left, the function goes up. As the function extends to the right, the graph goes down. Down means negative infinity. That's your last case. There is only 4 possible cases of end behavior, and they are all dependent on degree and leading coefficient. Let's recap. So this is your first case. Even and positive leading coefficient, even degree, positive coefficient, both going up. This first part does not change, both positive infinity. Second case, if it's an even and negative leading coefficient, there's a negative, both goes down, means both negative infinity, it goes down. Third case, if the power is odd and the leading coefficient is positive, the right goes up, the left goes down. The left goes negative infinity, goes down. The first statement is always describing the left, and then the second statement always describes the right, it goes up. And the last case, you have odd power degree, negative leading coefficient. Your left goes up, your right goes down. Your left, as x going to the negative infinity, the function goes to the positive infinity or going up. As x goes to the right, the function goes to the negative infinity, which means it goes down on the y-axis. And that is your end behavior of a polynomial function. There are only 4 possible cases, and it all depends on the degree and the sign of the leading coefficient. Thank you. You can watch the video again if you get confused.